Hey my friends, Sean Tierney here from theautomationblog.com with the 50th episode of the Automation Podcast. In this episode, I sit down with Louis Narais from Siemens to get all the details about the S7-1200 line of PLCs. I hope you enjoy. Louis, thanks for putting this presentation together. Can you introduce yourself to our audience?
Yes, Louis Narvaez. I'm the product manager for the S7-1200 basic controller for Siemens USA.
Excellent. I'm looking forward to the overview.
Thanks for allowing us to discuss the product, and hopefully as we go along you have some questions and that I can help answer, and we can move forward. So just to kind of get an idea, background of the different PLC options that we offer, the S7-1200, again, is considered our basic controller, but we also have other PLCs. Our S7-1500, for example, is considered our advanced controller, and it comes in different form factors. We have the typical, S7-1500 PLC, which is kind of the rack style modular type PLC. We also have the 1500 that's in a software controller, so it'll run on like a Windows IPC, or you can also have it with a Linux operating system. We also have the 1500 in a distributed form factor, so for smaller machines, you can get a kind of a compact 1500 that's kind of in the same form factor as our remote I/O, our ET200SP family of remote I/O. And then, of course, there's the S7-1200, which is what we'll be discussing today. Just to kind of get an idea how the S7-1200 basic controller scales in comparison to like our S7-1500. We call it the basic controller, but and it handles anything from like a micro automation, something you would see for like a micro PLC, all the way up to like medium-sized applications. It's engineered in TI Portal, which is the same engineering framework that all of our S7 family of controllers use, which makes it super easy whenever migrating from like a 1200 to a 1500, in case you run into an issue where you find that it's maybe a much more complex application that requires more memory or faster speeds, or just some capabilities that the 1200 doesn't exactly have. So this kind of gives an overview on the software that's used to program it. You can see that with the S7-1200, all you need is Step 7 Basic. If you have the fail-safe or safety variant of the 1200, you can also you just need a safety basic license. With the 300s, 400s, and S7-1500s, Step 7 Professional is required, and same thing with the safety license. You'll need a safety advanced license to program safety for any of these PLCs. One thing to point out is that when you order a Step 7 license, you automatically get a WinCC Basic license, which is used to program our basic panel HMIs. The other thing that it also includes is PLC Sim, which is an add-on that requires no license. It's used to simulate your PLCs in real time. Start Drive is used to commission our general purpose and servo drives. And then again, as I mentioned, WinCC Basic for the HMIs as well. The basic design of the 1200, it's typical brick style PLC. So you have integrated digital inputs and outputs, as well as analog ins, analog I/O. On the top of the CPU, you'll usually see the connection for a power supply to the CPU. This could be either 24 volt DC or AC voltage. The terminal blocks on the top and the bottom are removable, and you can even interchange them for push-in terminals. So, for example, for an application where maybe this is being installed on a machine that's got a lot of vibration and screw terminals may not be good for that, you can get push-in terminals as well. There's a slot for an optional SD card. The SD card can be either used for load memory, for storing user files, loading the user program onto the CPU if you have like serial machines, or even just firmware update type applications. On the front, there's also a slot for expansion boards. You can either expand the integrated I/O on the CPU. You can use it to maybe expand the communications options. There's a RS485 expansion board, or you can add a battery board, which is used to expand the real-time buffering clock. And then on the bottom, you can't really see it very well in this picture, there's a RJ45 port. Depending on the CPU model, you'll either have 1 or 2 ports. Those RJ45 ports can be used either for Profinet communications, for programming, for getting diagnostics, HMI connection, or just any other like TCP/IP communications. So it could be OPC UA, MQTT, Modbus TCP, things like that. And then your typical status LEDs for, CPU run mode, and then your I/O status. So this slide, it seems a little overwhelming. Seems like, a lot of part numbers, a lot of different variations, but in reality, it's not so bad as it seems. There's really just 5 different models of the 1200, and then within each model, there's different configurations. So, for example, the yellow box around indicates the fail-safe versions that are available. So we only have a safety version of the 1212, the 1214, and the 1215. We don't have a safety version on the 1211 or the 1217. The other configuration option I mentioned earlier, you have the option to wire 120 volts AC directly into the CPU for power. That's another configuration option. As well as for the digital outputs, you have the option to either have 24 volt DC discrete outputs or using relay outputs. So when ordering 1200 from your distributor or whoever, if you're trying to figure out which one's the right one, kind of looking at, let's say you want like a 1214C, and you look at kind of like this bottom configuration, AC, DC, RLY. AC basically stands for, the first set of letters is the power supply to the CPU. So DC would indicate 24 volt DC supply, AC would indicate 120 volt AC. The next set of acronym, DC, is just the input type onto the CPU, the digital inputs. So 24 volt DC, that's the only option. We don't have relay inputs that are built into the CPU. You can get that with like an expansion I/O card. The outputs you can get either in 24 volt DC, or RLY stands for relay outputs. And those relays can either be, AC or DC signals. This just shows the size difference between the different models. So the 1211 is the smallest, the 1211 and 1212 at 90 millimeters. That's just under 4 inches for scale. And then our 1217 is 150 millimeters, which is about 6 inches wide. Here's kind of just a brief overview on the specifications between the different models. Really, the main thing to take note between the different models is the different memory between the different ones. So, with the 1211, you've got a 50K of work memory and 1 meg of load memory. The 1212, it goes up a little bit more, the 1214, and so on. The other thing that changes between the two, you'll notice, is the amount of integrated I/O on the CPU. 1211, you've got 6 in, 4 outs. 1212, 8 in, 6 outs. And the 1214 and higher, you've got 14 in and 10 outs. And you get into the 1215, you also add there's an additional 2 analog outputs built in. Then the third thing that changes, I would say, is the expansion capabilities, which I'll get into in a couple slides. But basically, with the 1211, you only have the ability to expand communication options, and then that front option board slot that I pointed out. With the 1212, you have 2 modules, and the 1214 and higher, you can expand up to 8 local I/O. And they all support distributed I/O as well, up to 16 Profinet I/O devices. This slide just kind of reiterates some of the stuff I already discussed in terms of like the Profinet port and the dimensions. But one thing I wanted to kind of point out is we get questions a lot on processing speed. So this kind of if you look at the specifications of any Siemens CPU, it's always kind of the same structure. We don't really advertise an overall speed or cyclic update rate, because it really depends on what you're doing in your program, right? And so we kind of just do it based on instruction type. So With the 1200s, you get about 80 nanoseconds processing speed for any kind of binary or Boolean instructions. Typical normally open, normally closed, contact type operations. With word instructions, these things are like, moving registers, moving bytes, moving words. You get 1.7 microseconds per operation. And then for floating point math and arithmetic type stuff, you'll get about 2.5 or 2.3 microseconds. This talks about the expansion capabilities of each model. So as I mentioned with the 1211, in terms of I/O, you're kind of just stuck with the integrated I/O on the CPU, or you can expand that a little bit using a option board. But you can expand the communications options up to 3 modules to the left. With the 1212, you get up to 2 signal modules plus the 3 communication modules and the signal board. And then, like I said earlier, with the 1214 and up, you get up to 8 local I/O. So this is kind of busy, but I just kind of wanted to give an overview on the signal modules that are available with the 1200. So as I mentioned, on the front, you can expand using a signal board. With that, you can add 24 volt or 5 volt DC digital inputs, analog inputs, or stuff for measuring temperature, digital outputs, 24 or 5 volt DC, analog outputs, or even like a combo signal board. For digital input signal modules that stack on to the right of the CPU, kind of the same concept. You can either do 8 or 16 channels, including safety digital input card. Digital outputs, you can do the same thing, 8 or 16 channel, 24 volt or relay outputs, including safety. And then you can also have combo cards, 24 volt or relay, both inputs and outputs. For the analog inputs, 4 or 8 channel, 13 or 16 bit, depending on what your needs are. We have RTD, thermocouple, analog input cards, typical analog output cards, 2 or 4 channel, or you can get combo cards as well. And then we also have, we always kind of get people scratching their head or asking about what is a technology module. We always hear about that. Well, technology modules are basically specialized I/O cards that handle special functions. So we have signal modules that can handle weighing applications. So like if you have strain gauge or load cells or dosing applications, we have weighing cards that you can stack to the right of the CPU that can handle that kind of computation and stuff. We also have a card that's for condition monitoring systems. So vibration analysis type applications that's typically used for like predictive maintenance and preventative maintenance operations. And then we also have an energy meter card that obviously is used for measuring energy consumption. You can use it for, maybe OEE type applications, things like that. For the communication cards on the left of the CPU, lots of options. You can have GSM, GPRS, those are cellular type cards. You can also have RS-232, industrial Ethernet. We have serial communication cards available. You can expand adding OSI, IO-Link, RFID. We also have Profibus master and slave cards. On the front of the CPU, you can add a communications board, which is RS-485. So that can be used for like Modbus RTU, USS, or peer-to-peer. And then, as I mentioned earlier, the integrated Profinet port, supports industrial Ethernet, Profinet, Modbus TCP, OPC UA server connection, and even connection to MindSphere, which is our cloud platform. This kind of just summarizes all the different protocols that you can get from the 1200, either via the integrated Profinet port or, through the expansion communications cards. You can see, there's pretty much covers most of the major protocols on the market today. Profinet, Profibus, OPC UA server functionality, OSI, BACnet, CAN, TCP IP protocols such as Modbus, HTTP, MQTT, IO-Link, cellular, DNP3 for like RTU type applications and timestamping, RFID connections. I mean, there's basically a lot of flexibility, for any small to mid-size application. So this just kind of summarizes some of the accessories available as well. We have these simulator switches. So if you wanted to, if you order a 1200 starter kit, it automatically comes with these little simulator digital inputs. So you can use that to kind of test your program. We also have this expansion cable if you wanted to maybe have like your I/O on a separate rack below. Maybe if you're in a situation where you're running out of space on the cabinet, you want to have your PLC in the top rack and maybe a couple I/O cards on the bottom. There's a expansion cable. And then, we talked a little bit about the memory card. With the memory card, you've got options from 4 megabytes all the way up to 32 gigs. And that could be used for, loading programs onto the CPU. It could be used for extending the load memory of the CPU. And then the optional battery board, that could also be used for long-term backup of the real-time clock. So built in on the CPUs, you have these capacitors. You can have your real-time clock on the CPU buffered up to 20 days. With the battery board, you extend it up to a year. So if you lose power to the CPU for more than a year, your timestamps it doesn't lose its integrated timestamp. And that's pretty much it. Just wanted to kind of leave this here. We've got podcasts, scheduled with you, Sean, and these are kind of some of the topics that we have left that we wanted to leave with you guys. S7-1200, TI Portal, an overview on our remote I/O family, and then some of the motion capabilities of our controllers. If you guys want to get some more information, I always post kind of little nuggets on my LinkedIn profile, and obviously you can see this video on theautomationblog.com.
Absolutely. Thank you, Louis. Well, I hope you enjoyed Louis's presentation. I sure learned a lot about the S7-1200 from it. And if you did enjoy it, please give us a like and a share. And with that, I want to thank Louis again for taking time out of his busy schedule to sit down and go over the product line with us. And just want to thank you for watching as well. And with that said, that's it for this episode. Until next time, my friends, peace.